Imagine a time when everyone believed the Earth was the center of the universe. This was the accepted truth for over 1,000 years. People looked up at the sky and saw the sun, moon, and stars seemingly revolve around them. Then came Nicolaus Copernicus, a man who dared to challenge this ancient wisdom. He proposed a radical idea. The Earth was not the center but rather just another planet orbiting the sun. This simple yet revolutionary idea, known as the heliocentric model, sparked a revolution in scientific thought and forever changed our understanding of the cosmos. Copernicus's courage to question the established order and to seek a simpler, more elegant explanation for the movements of the heavens marked a turning point in history. It was the dawn of a new era, one where observation and evidence would challenge traditional beliefs and pave the way for modern astronomy. Before Copernicus, most people subscribed to the geocentric model of the universe. This model, championed by the ancient Greek astronomer Ptolemy, placed the Earth at the center of all creation. The sun, moon, planets, and stars were all thought to revolve around our planet in a complex system of circular orbits. This Earth-centered view was not simply a scientific theory, it was deeply ingrained in the religious and philosophical beliefs of the time. The Church, the dominant power in Europe during Copernicus's lifetime, embraced the geocentric model as it aligned with the biblical account of creation and reinforced humanity's central place in the cosmos. To question the Earth's central position was not merely to disagree with scientific dogma, it was to challenge the very foundation of their faith. Despite its widespread acceptance, the geocentric model had some glaring flaws. Astronomers struggled to explain the observed motions of the planets, particularly their occasional backward loops in the sky, using Ptolemy's system. These inconsistencies hinted at a deeper truth, one that Copernicus would eventually unveil. Nicolaus Copernicus was born in 1473 in Poland. He was a man of many talents, a mathematician, astronomer, physician, and even a church canon. His interest in astronomy led him to study the works of ancient Greek astronomers, including Ptolemy. While Copernicus appreciated the elegance of the geocentric model, he was also troubled by its inaccuracies. He began to ponder alternative explanations for the heavens' movements. Through years of meticulous observation and mathematical calculation, Copernicus developed his groundbreaking heliocentric theory. He proposed that the sun, not the Earth, resided at the center of the solar system. The Earth, along with the other planets, revolved around the sun in circular orbits. This simple yet radical shift in perspective elegantly explained the perplexing retrograde motion of the planets. The apparent backward loops were simply an illusion caused by the Earth overtaking and passing slower-moving outer planets in its orbit. Section 4. De Revolutionibus, a book that changed the world. Copernicus hesitated to publish his revolutionary ideas. He was aware that his heliocentric theory contradicted the prevailing scientific and religious views of his time. He feared ridicule from his peers and condemnation from the Church. However, encouraged by his close friends and colleagues, Copernicus finally agreed to publish his magnum opus, De Revolutionibus Orbium Coelestium, on the revolutions of the heavenly spheres. The book, published in 1543, the year of Copernicus's death, laid out his heliocentric theory in detail, providing mathematical calculations and diagrams to support his claims. De Revolutionibus was not an immediate bestseller. It was a dense and technical work, written in Latin, the language of scholars, making it inaccessible to the general public. However, its publication marked a turning point in the history of science, planting the seeds for a revolution that would blossom in the coming decades. Section 5. Shattering the Spheres. The Copernican Revolution was not a sudden paradigm shift. It was a gradual process of acceptance and refinement. Copernicus's ideas initially met with resistance, particularly from the Church, which saw the heliocentric model as contradicting Scripture. The idea that the Earth was not the center of the universe challenged the anthropocentric view of creation, a cornerstone of religious doctrine. Despite the initial resistance, Copernicus's work sparked a wave of scientific inquiry. Astronomers, mathematicians, and philosophers began to study Copernicus's heliocentric model, testing its predictions and exploring its implications. The invention of the telescope in the early 17th century provided further evidence supporting the heliocentric theory. Galileo Galilei, using his telescope, observed the phases of Venus, a phenomenon that could only be explained if Venus orbited the Sun, not the Earth. This observation provided compelling evidence in favor of Copernicus's model. Section 6. The heirs to a revolution. The Copernican Revolution did not end with Copernicus. His work inspired generations of scientists who built upon his foundation, refining and expanding our understanding of the universe. Johannes Kepler, a German astronomer, used meticulous observations of Mars to formulate his laws of planetary motion. Kepler discovered that planets move in elliptical orbits, not perfect circles as Copernicus had proposed. Kepler's laws provided a more accurate description of planetary motion, further solidifying the heliocentric model. Sir Isaac Newton, building upon the work of Copernicus, Kepler, and Galileo, developed his law of universal gravitation, which explained the force that keeps the planets in orbit around the Sun. Newton's work unified the heavens and the earth under a single set of physical laws, demonstrating that the same force that causes an apple to fall from a tree also governs the motion of celestial bodies. Section 7. The enduring legacy of Copernicus. The Copernican Revolution was more than just a change in our understanding of the universe, it was a revolution in thought. It taught us that we must be willing to question our assumptions, even those that have been held for centuries. Copernicus's courage to challenge the established order paved the way for the scientific method, a process of inquiry based on observation, experimentation, and logical reasoning. The Copernican Revolution continues to inspire us today as we explore the vastness of space, searching for answers to fundamental questions about our place in the cosmos. It reminds us that the pursuit of knowledge requires an open mind, a willingness to embrace new ideas, and the courage to challenge the status quo. As we continue our exploration of the universe, we carry with us the legacy of Copernicus, a man who dared to change our view of the cosmos, and in doing so, change the world forever.